Hello students, now we'll be talking about torque experienced by a current loop in a uniform magnetic field. Okay, uniform magnetic field. Okay, so here what I have done, I have drawn a magnetic field. This X shows that is magnetic field going inside the plane. Okay, and we have a current loop, that is this. This is our current loop whose size is A and B. Okay, now will this be experiencing a magnetic field force on it? Okay, what will be the direction of force? We know it is right hand palm rule. Okay, so for suppose for this loop, okay, for this side what will be the direction? The magnetic field is going inside. Okay, velocity is in upward direction, that is current is in upward direction, force will be in this direction. So suppose I say that force is, suppose F, I'll name this A, B, C, D. Okay, if I name this A, B, C, D, then what will be the direct force between AD? This will be force between AD. Okay, similarly if I check for here, magnetic field once again going inside, magnetic field is going inside, direction of current showing the thumb, force will be in the upward direction. Okay, so F, AB. Okay, here once again magnetic field going in this direction, current is in downward direction, the force will be in this direction, so this will be F, B, C. Okay, now finally here magnetic field going inside, current in the direction of thumb, force will be in downward direction. Okay, so let me name this F, C, D. Okay, here what will happen? What is the formula for force? That is F equals to ILB sin theta, that we have already studied previously. Okay, so if we calculate the force between this, as it is a rectangular loop, the length of this will be equal to this and length of this will be equal to this, which means that there is no other thing which will be varying, all the things will be same, and the direction of force are different, means FAD will be equal to FBC and FAB will be equal to FCD, which means that net force, okay, net force will be equal to 0, because this force will cancel out this force will cancel out this force, so net force on this system will be 0. Also the net torque net will be equal to 0, because all the things are in same direction, there will be no torque acting on it. Suppose we take a book, this is a plane. Okay, if anything is stretched from this and this side, what will happen? It will remain in same position and the forces will be cancelled. Similarly, if it is stretched from this side and it is stretched from this side, the things will remain same. Okay, now as the torque is 0 over here, what we will do? We'll just rotate this system by a small angle. We'll rotate the loop by small angle. Okay, so for that I'll draw it once again. Okay, I'm simply drawing the original condition. Okay, this is our original condition, original loop. So what we'll do, we'll just rotate it by some angle theta. Okay, we have rotated it by a small angle theta. Okay, if you want to see how it is exactly rotated, I will show you in this manner. Suppose this is a book. Okay, now if you can't see this, we'll take the top view. Okay, you can see it over here. What we have done, we have just rotated it by some angle theta in this manner. Okay, or you can rotate it in this manner also. Okay, so in this manner you can see that it will be rotated in either of the angle. Okay, you can rotate it in this way or you can rotate it in this manner. Okay, so what will happen over here? An angle will be formed over here. Now suppose once again we'll name it, it was A, B, C and D. Now again if we calculate the force, okay, if we again calculate the force on it, okay, then what is the force? The force on this will remain the same. Okay, it will be FCD, FAD, FBC, FAB, and this will be FCD. Okay, here you can say that this force and this force are again in the same line, and again it will cancel out each other. Even this force and this force are also in the same line. So if you go on to calculate net F, okay, it will once again remain 0. Okay, it will once again remain 0. But your net torque will not be equal to 0. Okay, I'll explain you how. What we have done, we had this book, we have rotated it by some angle. Okay, so what will happen, one force will act in this direction and one force will act in this direction. So what it will try to do, this force will try to rotate it in this side to keep it in original position, whereas this force will try to rotate it in this direction. Okay, so what will happen, if you see over here, okay, what it will try to do, it will try to rotate itself, which means that there is some amount of torque acting, because the line of action of both the force, this is the line of action of this force and this is the line of action of this force, both the line of action are not in same line. Therefore the net torque over here will not be equal to 0. Okay, I hope this much is very clear to you. Then I'll make a two short videos so that you can understand. We'll derive the formula for torque. Okay, till then keep studying.